Welcome to my YouTube channel, Data Pulse by Mose, the heartbeat of data learning. If you're new here, please make sure you subscribe to support me, and if you're a returning subscriber, I'm happy for you, and that keeps me motivated to keep sharing more content. Okay, we have functions now. Function names have the same rules as variables. Yeah, so I think we had some deep discussion on variables or identifiers. Wherever we say identifiers, just to remind you, we say identifiers, we don't use dollar signs to create variables. We said we do not use all using the keywords are not allowed when you create variables. We also said when we use the underscore to start with our variable or to create a variable, that variable will be a private variable. We said also we cannot create a variable starting with a digit. So those are some of the rules that we discussed in variables. So those rules also apply in function names. We'll be able to see what is this function names, or we'll be able to see the structure of creating a function. So the function is a block of related statements designed to perform a computational, logical, or evaluative task. So why do we have functions? The reason why we create functions is for us to be able to reuse our code. Yeah. So we'll see how we can create a function and then reuse the code of this function that we have created. So the idea is to put some commonly repeated done tasks together and make functions so that instead of writing the same code again and again for different inputs, we can do function calls to reuse the code. That is what I've already said. That is contained in the init over and over again. So we can wrap our operation in a single function, and then we can be able to reuse this function or this code when we call this function. We'll see how we do function calls. Another thing is we can create a Python function using the diff keyword. So diff, we have diff keyword that you must use when you're creating a function. Yeah, so let's see some of the different types of functions that we have. So we have two types of functions. One, we have a predefined function, and then we have in user-defined function. This is we call it inbuilt function. So this predefined functions. So we can either call them inbuilt functions or predefined functions. So these are functions that are already defined for us. And then we have user-defined functions. These are the ones that we can create for ourselves. Yeah. So the function which are developed by a programmer explicitly according to the business requirements are what we call user-defined functions. So these are the functions that we as programmers we create. That is function type number one. Function type number two is inbuilt function or predefined functions. So these are the functions which come along with Python software automatically, and we call them inbuilt functions or predefined functions. Yeah. So that is a second type of the function that we have. So a good example of inbuilt function is id, type. I guess we saw how we are using type. Yeah, we were using type to check the data type of our variable yesterday. That was yesterday, I guess we remember. So that was an inbuilt function that we were calling. So that function is already made for us, came with Python. So we are calling that function to check the data type of our variables. Then we have input, and then we have eval. Yeah, so these are some of the predefined functions. Yeah, so for us here we are going to look at now the user-defined functions. how do we create the user defined functions. So first, let's understand the different types of functions that we have. We have simple function, that is for the user defined functions. We have simple function, default argument function, required argument function, variable length argument function, anonymous function, filter function, reduce function, and then map function. So these are some of the functions that we need to know how we create them and the structure of each of these functions. So here is the format of the functions. Yeah, how we create a function and what these functions entail. So the first thing is the div keyword. So once in Python you define how you write a word div, Python, you understand you want to have a function. Yeah, so you have div as the keyword for creating a function, and then we have the function name. So this function name, as we said, it has the rules, yeah, which similar rules we said as the ones in identifiers or variables. So we have rules of creating these functions. Yeah, so you have the function name. So this function name can be any name that you need that defines what you want to do. For example, the sum. Yeah, I could say div sums. Let me say div sums. So I have my function name. I would understand I'm trying to get the sum of a certain values. Apart from the function name, we have the function parameters. So we have div, function keyword, function name, and then we have the parameters. So inside the parameters, we call them the arguments. Yeah, here we pass the arguments of our function. Yeah, so we'll see in other cases we may not need to have the arguments, but in other cases we can have the arguments. So we have div, keyword, function name, and then the arguments. After that, you need to have the full colonies. Yeah, so you need to have this to open your function. So once you input the full colonies and click enter, you will enter into the function body. So inside the function body now we have the operation of your function. You have what you need to do in your function. We said here we have here we define the tasks that we need to perform. Yeah, we define the evaluative tasks, the logical operation, computational operation we need to do in our function. So here, for example, we are trying to get the sum of x, y, and z. Yeah, so we are defining the task that we want to do for this function, and then you need to have the return type. Yeah, so return type returns the operation of your task, right? So that is now part of the structure of the function. And then after you've created your function, so your function ends at return statement. So the return statement is used to get you out of the function you've created. So now you need to call your function. So that is function calling. So to call your function, you use the function name. Yeah, we use the function name to call our function. So for this case, we were trying to get the sum of x, y, and z. We have input methods. So these input methods prompts the user to enter the values for x, y, and z. Yeah, so that is input method. So yeah, assuming I input a value 8, I input a value for y 2, and I input a value for z as 2. So what happens is this 8 is stored in x. Yeah, so once I call my function main, 8 will come here. Yeah, and then I have 2 and 2. So I will have the sum of these values. And then once I call the return statement, when I click enter, I will get the sum of these values. 8 plus 2 plus 2, which is 12. Yeah, so that is after I call my function. I call my function, that is function calling. As I've said, we call the function using the function name. So that is how we create the function. That's the structure of a function. Okay, so we have scope of the variable and a closer. So a closer is a function object that remembers values in an enclosing scope even if they are not present in that function. So a scope is a textual region of Python program where namespace is directly accessed. So we have a scope. We have a global namespace, an enclosed namespace, and a local namespace. So when you define a local namespace, this local namespace is only accessible inside this function, inside this inner function. So it cannot be accessed outside any other function. That is for the inner function. And then for the enclosed function, this enclosed function is only accessed inside the outer function and the inner function. That is enclosed namespace or enclosed variable, that is. And then we have the global namespace. So this global namespace can be accessed anywhere in your code. So you can have maybe other functions, yeah, following after this outer and the inner functions. So this global namespace or a global variable can be accessed anywhere in your code. Yeah, but for this local and enclosed are accessed maybe for the local namespace is accessed only for the inner function, and then for the enclosed namespace is only accessible for the outer and the inner function. But the global namespace is accessible in your whole code. Yeah, it's defined, or we can say it can be accessed by all by your whole code. Yeah, so that is the scope of the variables. That is global variable, enclosed variable, and the local variable. So now let's begin with symbol argument function. So for the symbol argument function, we don't need to have the arguments. Yeah, so that's why I said we have different structures for the different types of the functions. So the we have the div keyword, of course. We have the main, which is the function name, and then we have the parentheses, and then we have the full colons. So we have a function without any argument. Yeah, so that is the symbol argument function. No argument for this function. And then we have we request the user to input the values of that you want to perform the sum for. So we have x, y, and z. So the input method, as I said, it prompts the user to enter the values for the variable x, y, and z, right? And then return p, which gets us all, which now allows us to leave our function, and then we go ahead to call our function. So once we call our function, now we run this code, we are prompted to enter the values for x, y, and z. And then when we run, we get our the sum of x, y, and z. That is for the symbol argument function. So here we don't have the arguments in this case. Yes, a question?
I just want to ask, maybe I missed it. What do we call the that portion where we say p is equals to x plus y plus z?
Okay, so this p equals to x plus y plus z is storing the sum of these three inputs. Yeah, it's going to store the sum of x, y, and z. That is, for example, 10, 20, and 30. So once we have these values will give us 60. So this 60 will be stored in P. Yeah. So that is simply a variable to store the sum of these three inputs. Yeah. So I hope that is clear. Then we have, okay, a question.
So can we say that, can you go back to where, so can we say that the P is now representing the variable storing the operation for the function, for the simple function?
Yeah,
Or
it's
this is the
storing,
operation?
yeah, it's storing the operation for this function.
Okay, all
Yeah.
right, thank you.
So when we say return P here, now we're getting the sum of, of these values. Yeah. And then when we call this method, it gets the return of this sum, which is 60. Yeah. So that is the purpose of P. It's simply a variable, that is. And then we have the required argument function. The required argument function, a question? Okay. The required argument function.
Can you,
Uh-huh.
sorry, can, yeah.
Yeah.
So I wanted to just have clarity on this. So from the point of where we have our def to
Mm-hmm.
the part of return statements,
Mm-hmm.
that's the, it's sort of like the same thing, right? Eh, that's required for us to have an output. So like it's like a one thing, right?
Yeah. It's inside this method.
Oh, okay,
Yeah.
okay, thank you.
Yeah. So if you once you remember in Python, we talk about okay, we talk about spacing. Yeah. So once we get outside this, yeah, once we push our cursor outside the diff method, now we're getting outside this method. Yeah. So when we are in our method, all these lines of code should be in a straight line. Yeah, should be aligned. So that is for the simple argument function, actually for generally in Python. Next I want us to go to required argument function. So for the simple argument function, we said we don't need to have the arguments, and then for the required argument function, now we need to have the arguments. So it is required to have the arguments. So required arguments are the arguments passed to a function in a correct positional order. So the number of arguments in the function call should match exactly with the function definition. So here we have our arguments x, y, and z, and then we want to do the sum of these arguments x, y, and z. Yeah, so we store this sum in P. Yes,
I can't see the screen. Maybe
sure.
it's only me, the screen.
Then you have to check your network. It's the screen is visible.
Yeah,
Yeah.
yeah. Please check your network.
Okay, okay.
Yeah, fine. So we have okay. I was explaining that we're storing a value for this sum in P. So this required argument function, we need to input the, okay, we can input the values from the user, or we can predefine the values. Yeah. So we have a return statement which we use to get out of our function. So once we get out of our function, we store these values, or we request the user to input the values for x, y, and z. So we have the input method just as the way I explained earlier. This input prompts the user to input the values. So the user inputs 10, this 10 is stored in x, 20 stored in y, and then 30 is stored in z. And then we call our function main, and then we pass these arguments. So one thing you need to understand is these arguments must be the same as the arguments that you passed in your function definition. Yeah, so these arguments we are passing here are these ones here, x, y, and z, right? So that is the required argument function. I hope that is clear. Then we have default argument function. Now this is the one that our friend was asking, that we have 7 and then we are trying to we are trying to input for z. For this one, I think actually it was combining these values. Yeah, it had the required argument function and the default argument function. But again, you need to understand, in the function call, you need to pass these arguments, this actual number of arguments, as in the function definition, right? So this must not be x, y, and z. You can have a, b, and c, and then here you pass a, b, and c. So this a will be stored in x, the f value will be stored in x, yeah, and then the y value will be stored here, b value will be stored in y, yeah, and then for c will be stored in z. That is for the required argument function. Yeah, so it's not a must that this be x, y, and z. That is after defining your function parameters, right? So in function call, this argument must be the same as the function arguments in the function definition, right? We'll see this. We'll also get to understand this better later. And then we have default argument function. Here the thing is just here. This is the default value for our parameter z. So we have x and y, yeah, and then we have the default argument, which is z. So z has already been defined, or has already been assigned a value 70. So that means we don't need to input the value for z. So here already the value here is 70. It is a default value already, so we don't have to input or request the user to input this value. But when we input the values, we need to get the values for these other arguments, x and y, yeah. So we are requesting the user to input the values for x and y, whereby in this case he inputs 10 and 20. So 10 and 20 is stored here, right? And then we had a default value for z, which is 70. So 70 plus 20 plus 10 gives us 100. So in the function call, we pass only the arguments that we already input, yeah, for x and y. But we add a default value argument, but we don't have to pass in the function call. So in this function, let's read this. In this function, arguments can have default values. Yeah, so this argument is having a default value of 70. So we can assign default values to the arguments using an assignment operator at the time of the function definition. So you can define a function with any number of default arguments, right? So you could say, for example, so you could define y to be 50. But then here you could not have to use the you could not need to have the input from the user for the y, because it's already default, right? And then we have variable length function, right? So remember we said in a required argument function, the number of arguments you pass in function definition must be equal to the number of arguments you pass in the function call. But now we have variable length function. Now assuming I want to put any number of values in my function call. For example, I want to input 20 values when I'm calling my function. So in that case, we have the var keyword. Yeah, we have asterisk and then we have var keyword. So this Python, you understand, I want to put any variable length of values, right? And then we have the sum method. So what I'm doing here, I want to get the sum of the values that the user is going to input. So we have return sum, which is the method we have in Python, a default method that is used to get the sum of the values. So I'm going to get the sum of these values, which has a default length. Yeah. So we call our function, yeah, and then we input the different values any length of the values that we need to sum, right? So that is for the default variable length function. We use asterisk and then var, asterisk then var. So this will allow us to input any length of values in our function call. So in Python, there is a situation where we need to pass multiple arguments to the function. Such types of arguments are called arbitrary arguments or variable length arguments. So we use variable length arguments if we don't know the number of arguments needed for the function in advance. So for example, I want to get the sum of the student marks in a class. Yeah. So assuming I have 60 students. In that case, I could use the variable length argument function to get the sum of all these marks of these students. Yeah. So I call my function and then I input the values of all the marks of these 60 students. So that is the advantages of a variable length argument function. So you can have any length of the values in the function call, right? So I hope that is clear. Then we have the anonymous function as another type of the function that we have. So the anonymous function is also called nameless function. So there is a lambda keyword to define the anonymous function, whereas there other functions are defined using the diff keyword. Therefore, it is also called a lambda function. So the anonymous function has connectivity with the map, filter, and reduce. We see this. So when we define the lambda function or the anonymous function, we use the lambda keyword. So for this case, we said for the other function, we have the diff. That is for the other normal functions. But for the lambda function or the anonymous function, we use the lambda to define the anonymous function. So we have our parameters or arguments of x. So we have y equals to lambda of x, whereby we want to print the value for that value y, which is 30. So the output of this will be 30. So that is how we define the anonymous function. So for example, I want to get the cube of a certain value, right? I will need to use the lambda function to get the cube of that value. For example, here I have g. So this g is my function name. Yeah, just like this, we have main as our function name. So here g will be our function name. So this is the one we are going to call. And then we have lambda, which is the Python keyword that we use to create the lambda or the anonymous function. And then we have x as our argument. And then we want to get the cube of this x. So we have x times x times x. So this is the operation that we want to perform, just like this one. Yeah, here cube, we have diff cube. This is for the normal function, diff cube of y. So cube is the function name, y is our parameter, and then we have the operation we want to perform, y times y times y, which is the cube of y. And then we call the function name, which is cube, and then we pass the value of our y. So that is the same thing as the lambda or the anonymous function. So we have g as our function name, we have lambda as the keyword for the anonymous function, and then x as the parameter, all the arguments. So we have a value 7, which was stored in x. So our x is 7 times 7 times 7, which gives us 343. So that is how we use the anonymous function. Yeah. And then we have reduce. The reduce function is defined in the function module or functools module. Yeah, right. So when you want to use the reduce, you need to import this functools module. So like the map and filter function, the reduce function receives two arguments, a function and an iterable, right? A function and an iterable. So the reduce function takes two arguments. The first argument is the function. So this reduce function also has another function inside. Yeah, has um, as a function and an iterable. However, it doesn't return another iterable. Instead, it returns a single value. So here is how we can create a reduce function, or how we can use a reduce function. So the first thing is you need to get this reduce function. You need to import this reduce function from the functools module. So once we import this reduce, now we can use that function. So we have our list of 5, 8, 10, 20, 50, and 100. So we want to do the iteration of this list. Yeah. So this list, now when we call our function, or when we use our reduce function, we have the anonymous function whose argument is x and y. So we want to get the sum of x and the y, right? And then remember we said this reduce function also takes an iterable. So this iterable is our list now, right? So we are going to get the sum of this list values, which is 100 plus 50 plus 20 plus 10 plus 8 plus 5. So when we call this function, when we call this sum, we get the sum of these values, right? So that is how the reduce function works. So the reduce function, you need to understand, it takes the lambda takes two arguments, a function and an iterable. So if you use one argument in the reduce function, it will raise an error.